Hi, in this video I'm going to go through question 2 of the Math 2009 paper. So for this question, they give us a sequence of real numbers x1, x2, and so on, where x1 is 1, x2 is 3, and xn is defined as 2 times xn minus 1 minus xn minus 2 plus 1 for n greater than or equal to 3. So for example, for x3, that would be 2 times x2 minus x1 plus 1, which is 6. And in part 1, they want us to find x4 and x5. So we just need to use the formula that they give us in their definition, which tells us that x4 is equal to 2 times x3 minus x2 plus 1, and x5 is equal to 2 times x4 minus x3 plus 1. So now we just need to use the values of x2, x3 to substitute into these equations to find x4 and x5. So pause the video and try it, and then you should get x4 is equal to 10 and x5 is equal to 15, just by substituting the values of x3 and x2 from what they tell us that they are, and then using x3 and x4 into the formula for x5. Okay, for part 2, they want us to find real constants a, b, and c such that xn is equal to a plus bn plus cn squared, for n being 1, 2, or 3. So if we're only interested in when n is 1, 2, or 3, then that gives us 3 equations for x1, x2, and x3. And from before, we know that x1 is 1, x2 is 3, and x3 is equal to 6. And so if I call these equations 1, 2, and 3, then it's just a case of solving these 3 simultaneous equations for a, b, and c. So if you want to have a go yourself first, then pause the video now, but I'll show you one way to do it. So if I take equation 1 from equation 2 and equation 1 from equation 3 as well, then that's going to give me 2 equations in just b and c. So if I call these equations a and b, then I can take 2 lots of a from b. Then that's going to give me 2c being equal to 1, or that's the same as c being equal to a half. Okay, so now we have c, we can work out b using one of these 2 equations. So if I use equation a, then I'm going to get b is equal to 3 times a half equaling 2, i.e. b is equal to a half. And then if I use equation 1, I'm going to have a plus a half is equal to 1, and so a must be equal to 0. So our final values of a, b, and c are a equal to 0, b equal to a half, and c equal to a half. Okay, now for part 3, we've got to assume that the equation star from part 2 is true for all n, and then to use that to find the smallest n such that xn is greater than or equal to 800. So this was equation star from part 2, and remember we also said a is equal to 0, b and c were both equal to a half. So if we rewrite star using this, we see that xn is equal to a half n plus a half n squared. So if we're looking for xn greater than or equal to 800, then we're going to want a half n plus a half n squared being greater than or equal to 800 from this. So if I multiply both sides by 2, and then I can factorize this left-hand side, and that will give us n times n plus 1 greater than or equal to 1600. Now we can recognize 1600 as 40 squared, and this left-hand side is almost like n squared, so I suppose we should be looking around n equal to 40. Okay, so let's try n is being equal to 40. Then we see that n times n plus 1 is 40 times 41, and that's greater than 40 squared. And so this condition is satisfied, so xn is greater than 800. Okay, but is this the smallest n such that xn is greater than or equal to 800? Well, let's try for n being 39 then. Well, if n was 39, then n times n plus 1 would be 39 times 40, which is less than 40 squared. And so this condition isn't satisfied, and xn must be less than 800. And so we see indeed that 40 is the smallest n such that xn is greater than 800. Okay, now for this last part, we are giving a new sequence, y1, y2, y3, so on, and we're told that it's defined by y1 being equal to 1 and yn being yn minus 1 plus 2n for n greater than or equal to 2. And we are told to find a formula for yn in terms of n, and then approximately what is xn over yn for large n. So if yn is yn minus 1 plus 2n, then we can use this formula again to replace this yn minus 1. And using this, we see that yn minus 1 is equal to yn minus 2 plus 2 times n minus 1. So our equation becomes this. And then we can use this formula again to replace yn minus 2. And we see that using this formula, we see yn minus 2 is equal to yn minus 3 plus 2 times n minus 2. And so if I just follow this pattern, we'll eventually get down to y1, and we'll have 2 times 2 plus 2 times 3 plus all the way up to 2 times n minus 1 plus 2n added on to the end. So if we use that y1 is equal to 1 and then factorize all of these 2's, then we see what we have is 1 plus 2 times the sum of the integers from 2 till n. And we can use this formula for the sum of the first n integers to work out this. So because we're only wanting the sum from 2 up to n instead of from 1 to n, then we see we can get this from here by taking 1 off both sides. And so our formula becomes the sum of the integers from 2 to n is equal to n times n plus 1 over 2 minus 1. So if I just use this in here, we'll have this. And so if I just simplify this, we see that yn is equal to n times n plus 1 minus 1. Okay, so now we want to know what approximately is xn over yn for large n. So remember from before we said that xn is equal to a half times n plus 1. So for xn over yn, we're going to get a half n times n plus 1 from the xn all over n times n plus 1 minus 1 from yn. And if I write the half out front, it might be easier to see. What we have is a half times n plus 1 over n plus 1 minus 1. And when n is very large, then this minus 1 is going to become irrelevant. And this fraction here is going to be approximately 1. And so we see that xn over yn is going to be approximately a half times 1, i.e. xn over yn is approximately a half.